Hello everyone! This practice exercise is now concerned on absolute value linear inequalities. So we are done with discussing how to present the solutions for linear inequalities. So you might want to check the previous videos for that. But as of the moment, we are concerned with these three numbers here for practice exercise A for lesson number 3. And we are going to present this absolute value linear inequalities into the three different forms, which is number 1, solution set, number 2, a graph, and number 3 is interval notation. Take note that if we talk about absolute value linear inequalities, there are general rules that we need to follow to come up with the correct solutions. Number 1 here is still presented as a absolute value linear inequality. So we can actually use the general form for less than notation to come up with the linear inequality form. If you can still remember, if we have an absolute value of any variable, let's say x, is less than, or you could also be less than or equal to any constant c, the solution or in linear inequality form are all values of x between negative c and c. The other way of reading this is that we actually look for values of x which are greater than negative c but less than c. Do not worry if I have read this notation here as greater than, even if it looks like a less than symbol. I read it as a greater than because we started in the middle. Again, this is read as values of x greater than negative c but less than positive c. This is the general form of linear inequality form when we talk about absolute value linear inequalities following the less than symbol. If this symbol has equality, we just simply copy the equalities notations here. But since for number 1, it's similar to that, this absolute value linear inequality in linear inequality form is actually the values of x that are greater than negative 3 but less than positive 3. This is with the application of the general form. Now, if you're not yet sure if the general form is correct, you may pick any value here. Definitely, you may choose 0 as the easiest and substitute it in the given. Absolute value of 0 is 0, and it is still less than 3. That means 0 as part of this is correct. We could also pick here positive 2. Absolute value of positive 2 is positive 2, and it's still less than 3. For negative 2, which is still part of this range here, absolute value of negative 2 is positive 2, which is still less than 3. But if you're going to pick values outside of this range, let's say 4, absolute value of 4 is not is a positive 4, which is not less than 3. If we also not try to use negative 4, the absolute value of negative 4 is positive 4, which is still not less than 3. Even the negative 3 and 3 themselves cannot be substituted here because we don't have the equality symbol. That would mean this is the correct linear inequality form, copying the general form for number 1. Now that we are sure of this, and by the way, we can only be sure after checking, but now we already have checked it. So once we are sure of this, we can come up with the first expression of solutions, which is in the form of solution set. Again, as a reminder, since we talk about since we talk about inequalities, that would mean that the number of solutions are infinitely many. So we cannot use here the roster form, but rather we can use here the set builder form of set notation. Again, there are many ways to present this. Other references have different ways of presenting solution sets in absolute value linear inequalities. But let's just simply copy this notation and place it here, and that would actually complete our solution set. So it is read as values of x such that x is greater than negative 3 but less than positive 3, which is still correct. The second is by graph. So before when we graph linear inequalities, we actually look for the starting point. the direction, and the inclusion or the non-inclusion of the starting point. But for absolute value in linear inequalities involving the less than or equal symbols, we are going to use here the endpoints given by our linear inequality form. And those endpoints are the values here, the as your rightmost endpoint, and the value here as your leftmost endpoint. We need to plot them in this real number line. So you have -3 and +3. That's the first step. Instead of looking for a starting point, our first step here is looking for the endpoints. And again, endpoints are already given in the linear inequality form, copying the general form of absolute value linear inequalities involving less than or equal symbols. Next is instead of direction, we know that the values are just between -3 and 3. So we are going to shade all values between the two endpoints. So the values meet. It does not extend on both infinities, but they just actually meet here. And we have the boundaries of -3 and 3. And finally, for the last step, is to determine whether the endpoints are included or not. Looking at the given notation, since we don't have equality here, neither here, that would mean that we cannot actually use -3 and 3 in our as our solution, or they are not part of our solution. Because again, if we're going to try +3 here, the absolute value of +3 is +3, but it's not less than 3. Same as true with -3. The absolute value of -3 here is +3, which is still not less than +3. That would mean both of the endpoints are not included. And that in our graph, we are going to use the open or unshaded circles. It should be unshaded, so they may not be circles, circular notations. Yeah. Okay. So we have these as our notation for non-inclusion. And as we have used it's as the same as the linear inequalities without absolute value notations, we were going to include here parentheses because it's not included. Brackets for included, parentheses for not included. Just for us to be reminded of what would be our interval notation later on. And since they meet in between, imagine the two. Okay, last time I used the analogy of Son Goku or using his Kamihami wave. So I consider this as Son Goku and this is Vegeta. They are fighting. They are powering towards each other. So their hands are pointing towards each other, and then the powers just meet in between. Okay, this is our complete graph. Again, if you're going to compare with the previous video and the previous practice exercises, in the previous practice exercises, we noticed that our graph extends on either positive or negative infinity. But here, for absolute value linear inequalities involving the symbol or notation for less than or equal, they meet in between. They do not stand in infinities. Now, for our interval notation, we simply look at this area here, right? The rightmost, or the rightmost point is +3. The leftmost is -3. Separate them by a comma. And then enclose them in either parentheses or bracket. But since -3 and 3 are not included, and as looking at the graph, we have used parentheses, those are the hints that these are also parentheses. So this is now an interval notation saying that all values between -3 and 3 are part of the solutions. When we say between, it doesn't include -3 nor 3. Let us copy the same process as we go to number 2. But take note that in number 2, we have here the equal notation. So this is read as less than or equal. But still, it's less than. So we're going to use the same general form. And that would be the value of x, which is greater than or equal to -1, the negative of this value here, but less than or equal to the +1. Checking, you may use 0. Absolute value of 0 is 0. And yes, it's less than 1. So correct. You may also use here -1 and 1 due to the notation of equality here. Absolute value of +1 is +1, though it's not less than, but since we have an equal here, that's why it's called less than or equal. So 1 is still equal to 1. That would mean this is correct. As for the other side, -1, absolute value of -1 is +1, may not be less than, but since it's or equal, +1 is equal to +1, that would mean this linear inequality form is correct. Now that we are sure of it, let's come up with our solution set. Our solution set is a set containing x such that simply copy. X is greater than or equal to -1, but less than or equal to +1 enclosed in a brace. Take note that we used brace, not parentheses, nor brackets for solution sets. Please be reminded of that. The graph for number 2 will again be determined by the endpoints 1 and -1. So let's plot them here. We'll have -1 and +1. And we talk about all values in between. So our shading should be all values in between. So you may make your shading better than that what I am doing here. Now, because now let's decide on inclusion or non-inclusion. But since we have equality symbols here, we are assured that -1 is included. So we shade this area, shaded circle, and also 1 as part of the solution. And since they are included, we will not be using parentheses here, but rather we'll be using brackets. And same as earlier, the parentheses are both facing towards each other. The brackets will be the same thing. Sorry for that. Okay. Those are brackets. Bracket. Yeah. So this is our complete graph. I'm not necessarily saying complete because you could also add other values like 0, 1, and 2. But as for the graph is concerned, that's already okay. And finally, for our interval notation, we'll cover the leftmost value, -1, comma, the rightmost value, which is +1. And since we know that -1 and 1 are included, and even in our graph we use brackets, we shall also use here brackets. These are the different forms of solutions for number 2. Number 3, almost the same with number 2, it's just that the value here is 1/2 or a fraction. So simply copy our linear inequality form is x is greater than or equal to negative of 1/2, but less than or equal to positive of 1/2. You may want to check if you want. 0 is included, so absolute value of 0 is less than 1/2, correct? And if you're going to try both of these endpoints, since the equality symbol, they are also acceptable. And that would mean our solution set as values of x such that x is greater than or equal to negative of 1/2, but less than or equal to positive 1/2. Enclose, that's it. For our graph, again, endpoints are these values here, positive and negative of 1/2. Plot them on the real number line. Make sure that when you plot the real number line, the leftmost value or the values on the left are smaller than the values on the right, or smaller in value. And then all values in between, right? Oops, sorry for that. But since -1/2 is included, let me close this and also close this one and use brackets, not parentheses. Okay. For our interval notation, the leftmost value is -1/2. The rightmost value is 1/2, positive 1/2. Separate them by a comma and enclose them in a notation, either brackets or parentheses. Look at the graph. We have used brackets, so we shall also use here bracket, indicating that both endpoints -1/2 and 1/2 are part of the solutions. So this is how we represent our solutions for absolute value linear inequalities involving the symbols for less than or equal. If the symbol for inequality is greater than or even greater than or equal, we are going to have a different set of presentations for solution set, even for our linear inequality form, solution set, graph, and interval notation. That will be covered by the next video. So these are all the results first for practice exercise A. Thank you very much for watching. Please continue on practicing as we prepare for our next assessment soon. Goodbye.